Hi. In this example, we're going to talk about a problem that deals with a normal distribution as an approximation to the binomial distribution. The example states the following. If n times p is greater than or equal to 5, and n times q is greater than or equal to 5, then we will estimate the probability of fewer than 5 with n equal to 13 and p equal to 0.6. We want to use the normal distribution as an approximation to the binomial distribution. And if the np is less than 5 or nq is less than 5, then we will state that the normal approximation is not suitable. Whenever you are working with this normal distribution to approximate a binomial distribution, we have to make sure that we check the conditions. So we want to first check the requirement that n times p and n times q is greater than or equal to 5. So n times p is equal to 13 times 0.6, and that is equal to 7.8. And now we need to check n times q, and that will be equal to 13 times 0.4. Because remember that q is nothing other than 1 minus p, which is 0.4. So when you multiply the 13 times 0.4, the answer is 5.2. Now, we are done with checking the requirements that np is greater than or equal to 5 and nq is greater than or equal to 5. Now, the next thing we got to do is find mu, which is n times p, and we already did that calculation if you remember. So we can say that mu is equal to np, which is nothing other than 7.8, and sigma is equal to the square root of n, p, and q. So sigma is equal to the square root of n, which is 13 times p. Remember, p was 0.6 times q, which is 0.4. And when you plug that into your calculator, your answer is 1.766. Okay. Now the next part, I'm going to be working on the board. I wrote the information that we needed. We have the probability of fewer than 5, where mu was 7.8 and sigma is 1.766. Now we want to identify x and sketch the normal distribution. So x is equal to 5. And when we sketch the normal distribution, we're going to put mu somewhere in the middle, so 7.8. Sigma is equal to 1.766. And then we're going to put x somewhere over here. So here we have 5. Remember, we are working with a normal distribution as an approximation to a binomial distribution. So what we want to do is we want to go back to the problem. It says to find the probability of fewer than 5. Because it's asking for fewer than 5, we don't want to include 5. We need to, in this particular case, go a little before 5. So this number here will be 4.5. And we are looking for the area under this part. Now, how do we find the area, or how do we find the probability of x less than or equal to 4.5? So what we need to do is we need to transfer this to a z-score. So remember the z-score formula. The z-score formula says we're going to have x minus mu over the standard deviation. So we have z is equal to 4.5 minus mu, which is 7.8, over sigma, which is 1.766. And when you plug that into your calculator, your answer comes out to negative 1.87. Now, why do we do this? We need the z-score so that we can then find the probability or the desired probability. So we are going to redraw the graph using a standard normal distribution curve. So the mean will be 0, the standard deviation will be equal to 1, and then our z-score is going to be negative 1.87. What we need to do now is we want to find the probability that z is less than negative 1.87. And to do that, we are going to go to the normal distribution table. We are looking for z equal to negative 1.87, and negative 1.87 will be somewhere over here. So we can say that the probability of z being less than negative 1.87 is equal to 0.0307. And this is how you would approach this problem: a normal distribution as an approximation to a binomial distribution. What I'd like to do now is I'd like to do the same problem, but I want to use the binomial distribution using StatDisk. And to do that, we're going to go back to the computer. To do the problem using StatDisk, what you want to do is you want to go to triolastats.com. After you are in triolastats.com, you want to go to StatDisk Online. To sign in into StatDisk Online, I normally do it using Gmail, but you can sign in any way you want. What we'll do is we are going to go to probability distributions. And remember, the problem dealt with a normal distribution as an approximation to the binomial distribution. So I'm going to do the problem using binomial distribution. If we do the binomial distribution, let's ignore the fact that it's an approximation for now. The binomial distribution asks for two things. It asks for n and for p. Remember that n was 13 for our particular problem, and p was 0.6. We are going to evaluate. Okay. The first column talks about the x values. The second column deals with the probability of x. Okay. The third column deals with the probability of x or fewer. And then the fourth column, the probability of x or greater. Remember, our problem wants us to find the probability of fewer than 5. Because it's asking for fewer than 5, we do not include 5. So not including 5, then we need to look at x equal to 4. Fewer than 5 means 4 or fewer. And we say that the probability of 4 or fewer is 0.0320. That answer is fairly close to the answer that we got a couple minutes ago. Remember, the answer was 0.0307. So we are off by very little. And this makes sense because the problem that we did by hand, we did it using the normal distribution as an approximation. So the answer should be fairly close. Another thing that I want to point out is the calculations down here. So this is telling us that the mean is equal to 7.8, which confirms the calculations that we had. The standard deviation is 1.7664. Again, it confirms our calculations. And then it also gives the variance. I'm going to try something else. I am going to go to probability distribution. I'm going to go to the normal distribution. Now, when you are doing the normal distribution, we have to insert the z-value. Negative 1.87. At negative 1.87, the cumulative probability to the left, which matches our graph, is 0.03074. And again, that matches the probability that we found using the table. Okay, so now I want to recap what we did. We tackled a problem that dealt with a normal distribution as an approximation to the binomial distribution. And then we confirmed our answers using StatDisk and the binomial distribution. And then again, we confirmed the answers using the normal distribution and in StatDisk. If you have any questions on this or any other video, feel free to email me. See you soon.